Now in this video we will do composite function. Alright, now composite function is when you are given two functions f and g, and the composite can be denoted as f composite g, where the inner function is g and the outer function is f. So it can be written as f in the bracket of gx close bracket. Alright, the domain for the composite function is you can have as domain of inner intersect with domain of overall. Now, for example, if you are given fx equivalent to x squared minus by 16 and gx equivalent to square root x, and the question asks you to find the f composite gx and its domain. So first thing first, what you do is that write down your composite function f composite gx, and it is equivalent to your inner function is going to be gx, so f gx. Then so substitute your f and your gx inside the function, which is you have your gx function is square root x. Now you will have your inner function square root x as input for the function f. So your function f have x squared minus 16. So substitute your square root x into fx. So you will square root of x square minus by 16, and simplify, you're going to get x minus by 16. So this is the simplest form. So that is going to be the final answer for the composite. If they ask for the domain, what you have to do is domain of f composite g is actually your domain for inner, which is your domain g, intersect with your domain overall, which is domain of f gx. Just now what you have, where domain of g, if you look at over here, the domain of g basically gonna give you a square root function. So your domain of g can have x greater than equivalent to 0. Now domain for overall, which is over here, is x minus by 16, which is a polynomial function, a linear function. So this domain overall is actually x belong to a real number. So if you intersect with the domain of g, which is the inner function just now, x greater than 0, what you gotta have it, draw your real number line. Okay, your real number line. So the first one, you have domain of g at 0. So it is a solid because it's included the number 0, and it is to your right, going to your positive infinity. So this is 0. Okay, now this is basically domain of g. Now domain overall is your whole number, your real number. So basically it started from negative infinity until infinity. Now finding the intersection would be started from 0 until infinity. So your final answer of domain f composite g can be written as such: x belong to 0 to infinity with a 0 close bracket. So that is the final answer. Okay, now the question asking find g composite f and its domain. So what you do is that write down your g composite f x. So your inner function is fx, so you have your input here fx with the function g outer, and then substitute your fx function, which just now we have x squared minus by 16. Then you have the input x squared minus by 16. Now your function gx is square root of x, so if your input is x squared minus by 16, substitute into the square root of x, basically you're gonna get this. Now, to find the domain, again, domain of composite function is the domain of inner function intersect with the domain of overall function, the new function. So what you have is domain g composite f, means that you have to find the inner function is f. Your domain of f is what? Intersect with the domain of overall. So domain of f is your input here, x squared minus 16, is just a quadratic or a polynomial function. Thus, your domain would be a real number. Okay, now the domain for overall square root of x squared minus by 16, since it is a square root, so you take the whole function under the square root should be greater and equivalent to 0. So you have x squared minus by 16 greater and equivalent to 0. Now this one become a quadratic inequality. Solve using quadratic inequality method. So you have your right hand side equivalent to 0, and then you factorize, so you get x minus 4, x plus 4 greater than equivalent to 0, and you do the graphing to find the region of your inequality, which is you're gonna have plus here, so the region is gonna be over here. Alright, then your final answer, you will get x belong to negative infinity until negative 4 union with 4 until infinity. Now, since the domain of G composite F intersect between the two inner and overall, now if you intersect any number with a real number, will actually give you the one that the any number. Alright, so what I mean is that if you have, let's say, the first one, which is the domain of f is all real number, if you intersect with the domain overall, negative infinity until negative 4 and 4 until infinity, intersection of the two things will give you back the domain overall, which is x belong to negative infinity until negative 4 and 4 until infinity. Oh, another thing to take note is that the F composite G is never the same as G composite F. Okay.